Hello and welcome back. I want to spend a couple minutes today talking about what might be the bane of all pre-calculus students' existence, and that is our unit circle. Now, what I'm not going to talk about here is different techniques of remembering the numbers, um, or give you any kind of song. I promised you wouldn't want me to sing anyway. But what I'm going to do, I'm going to kind of deconstruct where these numbers come from. Um, and hopefully give you a way that even if you get into a bind and you forget them and you kind of blank out on a test, that if you remember where they come from, you can sit down and actually prove and show where they come from pretty quickly. It doesn't take too long. If you know the Pythagorean Theorem, that's really all there is to it. I am going to put a link in the description for one video that I like in particular that gives you a funny little jingle to remember the degrees and radians if you're having a hard time with that. But I'm just going to talk about the cosine and sine values on the outside and where those numbers come from. So I'm going to go to my next screen here, and I've got the same circle just with some triangles set up here. And notice what I talk about in class is the different families of angles. I'm going to start with my 45-degree family, and notice if I bring this up here, and the reason, so you got to remember, the whole reason it's called the unit circle is that the radius is equal to 1 all the way around. So all the way around this thing, if I act like these are triangles, then my hypotenuse is always going to be 1 going all the way around. And notice it's the exact same triangle. If I flip this over, it's the same thing in the second quadrant. And I can flip it upside down, go in the third quadrant, fourth quadrant. And the only thing that changes is the x and y values based on just what quadrant it's in, based on the signs of these things. And we've known for a long time that in the first quadrant, everything is positive. In the second quadrant, x is negative and y is positive. Third quadrant, everything is negative. And in the fourth quadrant, x is positive and y is negative. So where do those numbers come from? We're going to look at the 45-degree triangle real quick because that's the easy one. So that's a bigger 45, 45, 90 triangle. Again, hypotenuse is 1, the radius of the circle. And this we can do straight up with the Pythagorean theorem. Because we know that if it's an isosceles triangle, if the angles are the same, then the sides must also be the same. So we can just use our a squared plus b squared equals c squared. In this case, I'll use x for the two sides, equals 1 squared. Combine our like terms, and then divide by 2. So we got x squared equals 1/2. Take the square root of both sides. So we have x equals the square root of 1/2, which we can clean up a little bit to 1 over square root of 2, which is mathematically correct, but we like cleaning up radicals in the denominator. So we multiply by our fancy 1, and it becomes root 2 over 2. So that means each leg is the same at root 2 over 2. And lo and behold, if we go back to our unit circle, we see that my values for the x and y for the x and y values here are root 2 over 2 and root 2 over 2. So literally what that means is the x and the y is that, and we know also from SOHCAHTOA and our basics of trig that if we look at these sine and cosine values, they are root 2 over 2. Opposite over hypotenuse, adjacent over hypotenuse, all the same thing. And of course, tangent, I've got tangent on here too. That's just equal to 1. So that's where the 45-45 triangle comes from, a little more straightforward. And again, as we go across in the different quadrants, it changes signs on us. Now, for the 30-60 family, so there's my 60-degree angle, and notice if this is my 60-degree angle from the origin, then this is 30 up here. That's easy enough to see. And if I bring my 30-degree angle in here, it's the same thing, just kind of backwards. So this time my origin angle is 30, my reference angle, and then my larger angle up here would be 60. And that's why if you look at the coordinates, root 3 over 2, 1/2, and sorry, root 3 over 2, 1/2, or 1/2 and root 3 over 2, same thing, just backwards. And again, it's the same thing in the different quadrants. The 30, 150, 210, 330, all the same thing, root 3 over 2 and 1/2. And then the 60, 120, 240, and 300, all the same, just with different signs depending on what quadrant you're in. So where do those numbers come from? That's a little bit trickier to see. So what I've done, I've kind of flipped my triangle over because the easiest way to see where those values come from is to make a mirror image of this triangle. So I've got my base triangle, 30, 60, 90, and if I bring up just a mirror image of that thing and clone it, all of a sudden, what do I have? Well, I know this is 60 degrees down here, and I know this is 30, which makes the whole angle 60. So I have an equilateral triangle where all three sides are 1. And so if it's a mirror image, just common sense tells you that this side here of your original triangle has to be 1/2. So the distance, so the side opposite the 30-degree angle is 1/2. And then to find our longer leg opposite the 60 degree, now we just go back to our Pythagorean theorem. So again, I'll set that up at 1/2 squared plus 1 squared, check that, plus x squared equals 1 squared. So that's 1/4 plus x squared equals 1. Subtract 1/4, we have x squared equals 3/4. Take the square root of both sides. So x equals the square root of 3/4, which we can clean up to root 3 over 2. So again, if you think of it this way, then if you look at the 30-degree angle, then that tells you that your sine is 1/2 opposite over hypotenuse. And it tells you your cosine is root 3 over 2. Similarly, it's backwards for the 60-degree angle. For the 60-degree angle, your sine is root 3 over 2, and your cosine is 1/2. And sure enough, that is what we see on our unit circle. So for 30 degrees, cosine sine, we know the x is the cosine, the y is the sine. And then 60 degree, the x is the cosine is 1/2, and then the sine root 3 over 2. So again, that is where those numbers come from. I hope this helps a little bit. There are, again, if you're having a hard time remembering the sequence and just want kind of a device to help you remember all of those different things, and if you're going to do a blank unit circle for a test or something like that, or for an assignment, there's a bunch of videos out there, and I will link to one that'll help you out with the degrees and radians that I use in class a lot. So again, I hope this helps. Thank you for watching. If you want to see some more videos about pre-calculus and trigonometry as we go on through the year, please feel free to subscribe to my channel. Thank you again. Have a great day.